Hello viewers, in today's lecture we are going to solve some important problems related to vectors. So the first problem is, here we are given vector A I cap plus 4j cap plus 2k cap, vector B is 3I cap minus 2j cap plus 7k cap, and vector C is 2I cap minus j cap plus 4k cap. Find a vector D which is perpendicular to both vector A and vector B, and the dot product of vector C and vector D is given as 15, right? So here the vector D is perpendicular to vector A and D is perpendicular to vector B. So this implies that the dot product of vector D and vector A should be 0, because if two vectors are perpendicular, then their dot product is always 0. Similarly here vector D dot vector B is equal to 0. Now suppose that let vector D is equal to say xi cap plus yj cap plus zk cap, right? Now vector D dot vector A, here we have vector A and here we have vector D, and we know that if we wish to find the dot product of two vectors, then their corresponding components are multiplied and then we add them. So here we have x times 1, here we have 1, so this implies that x into 1 plus y multiplied 4, and then we have z multiplied 2, right? This is equal to 0. So this can be written as x plus 4y plus 2z equal to 0. Now vector D dot vector B gives us x times 3, then we have y times minus 2 plus z times 7 is equal to 0, right? So this can be written as 3x minus 2y plus 7z equal to 0. This is equation 1, this is equation 2. Now we are also given C dot vector D is equal to 15. So vector C is this vector and D is this vector. So therefore their dot product implies x times 2 times x, because C dot D is given, and then we have minus 1, here we have minus 1 times y, then we have 4 times z, right? That is equal to 15. So 2x minus y plus 4z equal to 15, and this is equal to 3, right? Now we have to solve these three equations in order to find the values of x, y and z, right? So what we will do, we can first solve equation number 1 and 2. So let us eliminate y from equation number 1 and 2 and multiply this equation number 2 by 2, right? So we have x plus 4y plus 2z equal to 0. This is equation number 1, and if we multiply equation number 2 by 2, we get 6x minus 4y plus 14z equal to 0. Now if we add these two equations, these two get cancelled. We have 7x plus 16z equal to 0, right? Now this equation can be taken as equation 4, and now let us take equation number 2 and equation number 3, and let us now multiply equation number 3 by 2, right? So and take equation number 2 as such, that is 3x minus 2y plus 7z equal to 0, and when equation 3 is multiplied by 2, we get 2 to the 4x. Here we have minus 2y plus 8z equal to 30. Now if we here we have added these two equations. Now we will subtract these two equations, so y get cancelled, and here we have minus, so we have minus x, and here we have minus, so 7z minus 8z is equal to minus z equal to minus 30. So x plus z can be written as equal to 30. So this is equation number 5. Now we have two equations in two variables, right? So let us solve these two equations, and let us multiply this equation by 7. So we get 7x plus 7z equal to 210. Now let us subtract these two equations. So here I am writing this equation. So here we have 7x. This is 7x plus 7z equal to 210. Now if we subtract these two equations, these two get cancelled. Here we have 16z minus 7z is equal to 9z, and here we have minus 210. So z is minus 210 by 9, and this is minus 70 by 3, right? Now when z is minus 70 by 3, we can obtain the value of x from this equation by substituting this value of z here, right? So we have x minus 70 by 3 equal to 30. Now x is equal to 30. Taking this term to this side, we have plus 70 by 3. So this is 90 plus 70 divided by 3. So we have 160 by 3, right? So the value of x is 160 by 3, and the value of z which we have obtained is minus 70 by 3. Now in order to find the value of y, let us substitute these two values in equation number 3. So we get 2 times of 160 by 3. Here we are substituting minus y plus 4 times minus 170 by 3 equal to 15. Now if we solve this equation, we get y is equal to 320 by 3 minus 280 by 3 minus 15, and this is equal to 320 minus 280 is 40 by 3 minus 15, and this is 40 minus 45 by 3, and that is equal to minus 5 by 3, right? So therefore we have obtained the values of x, y and z, and therefore our vector d which is perpendicular to both a and b, and which is given by this vector, is equal to vector d is the value of x is 160 by 3 I cap, the value of y is minus 5 by 3 j cap, and the value of z is minus 70 by 3 k cap, right? So this is the required vector. Let us take this question. If a cap and b cap are unit vectors inclined at an angle theta, then we have to prove that. We have to prove sin theta by 2 equal to half magnitude of a cap minus b cap. Here cos theta by 2 equal to half times magnitude of a cap plus b cap, and then we have tan theta by 2 equal to magnitude of a cap minus b cap divided by magnitude of a cap plus b cap. Now here we have shown two unit vectors which are inclined at an angle theta. Now viewers, here we will apply an important concept in vectors, that is vector a dot vector a is equal to the square of the magnitude of vector a, right? So here what we will do, we will take a cap minus b cap, right? Now a cap minus b cap is equal to say c cap, right? So therefore if we apply this rule to C cap vector, so we have C cap times C cap is equal to square of the magnitude of vector C cap, right? Now C cap is A cap minus B cap dot A cap minus B cap, and here we have the square of the magnitude of A cap minus B cap, right? So here we have substituted the value of C cap. Now this can be written as, the product can be written as A cap dot A cap minus A cap dot B cap minus B cap dot A cap minus that is plus B cap dot B cap, and this is equal to square of the magnitude of A cap minus B cap. Now we can write this as A cap dot A cap is square of the magnitude of A cap vector, then here we have 2 times of A cap dot B cap, then here we have square of the magnitude of vector B cap, right? Now we know that A cap and B cap are unit vectors, so the magnitude of A cap is 1, the magnitude of B cap is also 1, and A cap dot B cap can be written as A cap, here we have B cap cos theta, right? This is by the definition of dot product. Now this is 1, this is 1, and here we have cos theta, so we have cos theta. So substituting these values here, we obtain square of the magnitude of A cap minus B cap. Here we have 1 square, here we have 2 times cos theta, and here we have 1 square. So we have 1 plus 1, 2, and we have 2 minus 2 cos theta, and we can write it as 2 times 1 minus cos theta, and 1 minus cos theta can be written as 2 times of sine square theta by 2, right? So this can be written as 4 times sine square theta by 2. So therefore we have this expression. Now taking the square root of both sides, we get magnitude of A cap minus B cap is equal to 2 sine theta by 2, right? Taking the square root of both sides. So this is our first result which we had to prove, right? Now let us take the second result. Now viewers, for proving or in order to prove this result, what we will do, we'll again make use of all these steps with some minor changes. So I am not solving it here, and I am just making the changes in this solution itself, right? So here we have the magnitude of A cap plus B cap. Here we had the magnitude of A cap minus B cap. So here we will replace it by plus sign, right? So here I am replacing the negative sign with positive sign, and we will follow the same steps. So here we have plus sign, here also we have plus, here also we have plus, right? Now here we have plus, here we have plus, here we have plus, and here also we have positive sign, right? Now here we replace it by positive sign, here we have the positive sign, and here also we have positive sign, and here we have also positive sign, here also we have positive sign. Now this is 1 plus 1, 2, 2 plus 2 cos theta, and here we have 2 times 1 plus cos theta, right? Now here we can write for 1 plus cos theta, we know that this is 2 times cos square theta by 2, and we have 4 times cos square theta by 2, right? So therefore we have obtained the square of the magnitude of a cap plus b cap is equal to 4 times cos square theta by 2, right? Now taking the square root of both sides, we get magnitude of a cap plus b cap is equal to 2 cos theta by 2, right? So this is our second result. Now in order to obtain the third result, what we will do, we will divide this expression by this expression. So what we will get, we can divide these two equations. So we have the magnitude of a cap minus b cap divided by magnitude of a cap plus b cap, and here we have 2 sine theta by 2, and here we have 2 cos theta by 2, and if we cancel these two, we have tan theta by 2. So this is our third result, right? Now let us take this problem. If vector alpha is given as 3i cap minus j cap and beta vector is given as 2i cap plus j cap minus 3k cap, express beta in the form vector beta is equal to vector beta 1 plus vector beta 2, where beta 1 is parallel to vector alpha and beta 2 vector is perpendicular to vector alpha, right? So here we have shown that vector beta 1 is parallel to vector alpha. So we know that when two vectors are parallel, then one vector is equal to the scalar multiple of the other vector, or we can write vector beta 1 is lambda times this vector alpha, right? Okay, and here vector beta 2 is perpendicular to vector alpha. This is pi by 2 angle. So we know that the dot product of two vectors is always 0 when the two vectors are inclined at an angle of 90 degree. So here vector beta 2 dot vector alpha is equal to 0. So here we have the first equation and here we have the second equation, right? Now we are given that vector beta is sum of vector beta 1 and beta 2. Now let us take the scalar product on both sides with vector alpha, right? So what we will do, we will write vector beta dot alpha. It means we have to take the dot product on both sides with vector alpha. So here we have alpha dot vector beta, then we have alpha dot vector beta 1 plus alpha dot vector beta 2, right? Now we will find the value of alpha dot beta here, and alpha dot beta is given by 3i cap minus j cap dot product with 2i cap plus j cap minus 3k cap, right? So by the definition of dot product, we have 3 times 2, then we have minus 1 times 1, plus here we have no z component, so we have 0 times minus 3 equal to 0, right? So this is 6, this is minus 1 equal to 0. Sorry, it is not 0, it is simply 3 to the 6, minus 1 into 1 is 1, and here we have 0. So this is 6 minus 1, 5, right? So here we will substitute the value of alpha dot beta as 5. Now what is alpha dot beta 1? So what we will do, we will find the value of beta 1 from this equation. So we have here we have alpha dot beta 1 can be written as alpha lambda times vector alpha plus alpha dot beta 2 is 0, right? So we have 5 is equal to lambda times alpha dot alpha, and this is lambda times alpha, the square of the magnitude of vector alpha, right? And what is the magnitude of vector alpha? We have square root of 3 square plus minus 1 square. So here we have 9 plus 1, that is equal to square root of 10, right? So here we have lambda times 10. So lambda is equal to 5 by 10, that is equal to 1 by 2, right? Now if we substitute this value of lambda in equation 1, we have vector beta 1 is equal to half of vector alpha, right? So this is half times the value of vector alpha is 3I cap minus j cap. So this is the value of vector beta 1, right? So this is 3 by 2 I cap minus half j cap. Now the value of vector beta 2 can be obtained from this equation. Say this equation is equation 3, and beta 2 can be written as beta minus beta 1, right? Now vector beta is given as 2I cap plus j cap minus 3k cap, and minus beta 1 is your 3 by 2 I cap minus half j cap, right? Now beta 2 vector can be obtained by subtracting these two vectors. So we have 2 minus 3 by 2, that is 2 minus 3 by 2 is 4 minus 3 1, that is half I cap, and then we have here plus half. So 1 plus half is 3 by 2 j cap, and then we have minus 3k cap, right? So viewers, so this is how we have calculated the value of vector beta 2 and vector beta 1. Now the vector beta can be now written as from this equation, vector beta 1 is your 3 by 2 I cap minus half j cap, and the vector beta 2 is half I cap plus 3 by 2 j cap and minus 3k cap, right? So this is the sum of these two vectors to obtain the value of vector beta. Now let us consider an important problem. Find a unit vector. Find a unit vector perpendicular to the plane ABC, where ABC are the points 3, minus 1, 2, 1, minus 1, minus 3, and 4, minus 3, 1 respectively. So here we are given 3 points, and we have to find a unit vector that is perpendicular to. See, this is like this. The vector n cap, it looks like this. So we have to find a unit vector that is perpendicular to this plane ABC, so that this angle and this angle, that is angle DAB and angle CAB are here we have angle CAD, right? So angle DAB and angle CAD both are pi by 2, that is 90 degrees. So n cap is perpendicular to vector AC and n cap is also perpendicular to vector AB. It means this vector n cap is perpendicular to this plane ABC containing vector AC and vector AB, right? So here what we will do, we will assume vector AC as vector A and AB as vector B, and we will find, in order to find this vector n cap, we will find the cross product, that is the vector product of vector A and vector B. This is vector A and this is vector B. So vector A cross vector B is mod of vector A, this is mod of vector B, that is magnitude of vector A, magnitude of vector B. Sin theta, theta is the angle between these two vectors, and n cap, right? And we also know that if we take the magnitude of both sides, we know that vector the magnitude of vector A cross vector B is equal to magnitude of vector A, magnitude of vector B, and sin theta, because the magnitude of n cap vector is 1, right? So this is equation 1, this is equation 2, and if we divide equation 1 by equation 2, vector A cross vector B divided by the magnitude of vector A cross vector B is equal to, we will substitute the value of A cross B here, and we will substitute the value of the magnitude of vector A cross vector B from this equation. So here we have this term, and we see that this get cancelled, this also get cancelled, and sin theta get cancelled. So therefore we are left with the unit vector n cap, and n cap is written as A cross B divided by the magnitude of A cross B, right? Now vector A is vector AC, and AC can be written as OC minus OA, and the point C is 4i cap minus 3j cap plus k cap, and then we have OA, that is vector point A is 3i cap minus j cap plus 2k cap, right? So this is simplified as I cap minus 2j cap, and then we have minus k cap. Similarly, vector B, that is vector AB, can be written as vector OB minus vector OA, and OB is I cap minus j cap minus 3k cap, minus OA vector is 3i cap minus j cap plus 2k cap, and this is simplified as minus 2i cap and minus j cap and plus j cap get cancelled, minus 3k cap and minus 2k cap minus 5k cap, right? Okay, so we have obtained the value of vector A and vector B. Now we will find the cross product of vector A cross B, and this is given by the determinant I cap, j cap, k cap, and the components of vector A will be written in row number 2. So here we have 1 minus 2 minus 1, and the components of vector B will be written in row number 3. So we have minus 2, here we have 0, and here we have minus 5. Now if we evaluate this determinant, we get, so therefore the cross product of vector A and vector B is 10i cap plus 7j cap minus 4k cap, right? Okay, now here we can substitute this value. So we have 10I cap plus 7j cap minus 4k cap and divided by the magnitude of A cross B, right? So the magnitude of this vector is square root of 10 square plus 7 square and plus minus 4 square. So this is 10I cap plus 7j cap minus 4k cap and divided by, and this is equal to square root of 165, right? So therefore this vector n cap is given by 10I cap plus 7j cap minus 4k cap divided by square root of 165.